in a day or two. If you have questions during the webinar, there's a chat box, which probably most of you guys are in right now. And then if you look below that, there's a little box with a question mark on it. If you guys put your questions in there and then upvote the ones that you like the most and want to hear answered the most, that's where we're going to be answering a lot of the questions from after the fact. So in terms of the schedule, we'll do like quick round of intros. We'll do quick 5 to 10 minute presentations from Unstructured and then Chroma and then LangChain. And then we'll jump right into questions because we know there's a lot of questions. There's already a lot in that channel. So just put even more there, upload the ones that you want to hear answered, and we'll get to those in that order. Yeah, there's there's a lot of things in LangChain. Today we'll be talking about retrieval. So please try to keep questions relevant to retrieval. I think that's all the logistical stuff. It's pretty lightweight. Maybe we can do some quick intros now before getting started. Matt, do you want to go?
Yeah, hi, I'm Matt Robinson from Unstructured. I'm one of the developers on our open source library. We focus on data preprocessing for LLMs. We also have Ronnie Hozada floating around in the audience somewhere, who's one of our developer advocates. So I'm really excited for this.
Awesome. And Anton?
Yeah, hi, I'm Anton. I'm one of the co-founders of Chroma. We build retrieval systems for AI.
Perfect. All right. And I'm Harrison, one of the co-founders of LangChain. So with that, we can get into some presentations. Matt, you want to start?
All right. Let's kick off here. So I'll share my screen here real quick. All right. You got my screen?
Yes.
All right, perfect. So we'll start with just a quick introduction to what Unstructured is and what we do. So like I mentioned, we're focused on data preprocessing for LLM applications. So I know a lot of you are probably here for all of the advanced retrieval techniques, but before you get to the advanced retrieval techniques, you got to get your documents from raw format and into your vector database. And so that's what we focus on. We've got a open source repo, and we preprocess all sorts of different document types. You can see them over here. So we're about 25 different document types now. Then we also make that available through an API. So if you don't want to go through the trouble of getting things up and running locally, you can use that. We've got lots of integrations with LangChain. So check out the integrations page over on the LangChain site here. You can see a whole bunch of them. If you use the file loader, we'll even detect the file type for you and route it to the appropriate partitioner, and then get it ready to put into your vector database. So some of you might be familiar with us. We'll go through an example workflow of how to go from raw documents to a Chroma vector database here, and then we'll also point out a couple of new features that we've recently added that might be helpful for you. So what we're going to do here is just write a very simple summarize the news of the day application. So previously, without all of this tooling, this would have been a really kind of involved project. With Unstructured, you can use our partition HTML brick from our core library. And then what we're going to do is just go to the CNN Lite website and then just grab a bunch of links. So you can see this logic over here. When we preprocess data, we grab a bunch of metadata that then gets added to the vector database, so you can condition searches and that sort of thing. One of the pieces of metadata that we recently added for websites in particular is grabbing out links. And so it's really easy to go to that website, find all of the links, and now we can have a list of URLs that we can crawl for our little news summarization application here. We're also grabbing other sorts of metadata like page numbers. We're starting to grab things like section numbers and that sort of thing to make things easy to search in vector databases. So once we have all of that, we can go and grab one of our loaders from the LangChain library. So in this case, we'll grab the unstructured URL loader. We can just pass it all of those URLs, let it rip, and now it's just going through, finding all of the text in the news articles, Then once that's done, we'll have a bunch of LangChain document objects. Once it's in that form, really easy to upload it into a vector database like Chroma. We'll just use the vector store from the LangChain library. We'll upload it, and then we can run a similarity search to find news topics of interest, and then run them through the LangChain summarization chain to get a summary. With this workflow, we're able to create a nice little news of the day summarization app in I counted, I think it was less than 24 lines of code. Really a nice simple workflow there. Let's see. I'll pause and see if there's any questions before we move along.
I have one at a high level, Matt.
Oh yeah, go for it.
Like, and this may be a bit like, this may sound a bit basic, but I'm sure there's a lot of nuance here. Like, what does like the difference like partition HTML and partition Markdown like actually do? Like, what are you pulling out, like different types of elements? Like what is the different? Because all the like HTML and Markdown can both just be represented as like a string. So what exactly are you guys kind of like adding in and doing?
Yeah, we'll have a logic that goes through the document, and depending on the document type, we'll apply different logic to figure out different element types. And we'll go through and be like, hey, like this looks like a title, this looks like a list, this looks like body text. Depending on the document type, we'll do that in different ways. If you're talking about a PDF, we'll use document image analysis models to go through and look for visual clues like, hey, like this is bold and underlined, probably a title. We see like the bullet points here, like probably a list. If we're using something like HTML, we're using like tags and like information like that. If we're like looking at plain text, we might actually even look at the structure of the text itself to get some clues about that. And what that allows us to do is identify things like sections and that sort of thing that make it easy to chunk and group text. Importantly, what we do is for all of these document types, we pre-process them and then output them all in the same format. So from your perspective, it doesn't really matter if it's an HTML document, a Markdown document, a PDF. Goes into unstructured and then comes out all in the same structured format.
And then you mentioned PDFs. I know those are like the most popular types of documents or those are the trickiest ones to often work with, and so they're the most popular ones that we get questions about. What are you guys using under the hood? Are you using a different package? Do you have your own kind of like technology?
It's actually the logic is actually like a little bit nuanced. So we actually use different PDF processing techniques depending on what the user's trying to do. We've got what we call our high res option, which is model driven. So if you use that, it will go and kind of look for bounding boxes and that sort of thing in the document, label them, and then extract the underlying text. One of the other features that is available with that is table extraction. As part of that, we've got something called a table transformer model that'll go through, look for tables, extract the tables, and then they'll be available as both plain text and HTML. Some documents don't need all of that, and in some cases you want to just process them really fast and don't really need like the model-driven stuff. In that case, we'll use under the hood logic from things like PDF Miner and that sort of thing, and pull out text, and then you basically kind of like just process the plain text. Depending on what you're trying to get out of it, and what your priorities are, there are a couple of different options for processing PDF specifically.
Cool.
All right. Any other questions from the chat? If not, I'm just going to show one last thing here really quick. So one of the things that we've been recently adding to make it even easier to go from your raw documents to documents that are ready for downstream LLM use cases is something that we're calling connectors. So the idea here is a lot of people have their documents in SharePoint or S3 or Azure Blob Storage and that sort of thing, and they just want to point they just want to point us at that that document source and process everything, and then just kind of have the output available. And so we started working on this thing called connectors. And so this is showing an example with S3. And so you can go and point it at an S3 bucket, and that could have PDFs and HTML documents and PowerPoints and Word documents. Doesn't matter. You can just point it at that, use our CLI tool, and it'll go through and pre-process all of those documents. And then on the other side, you'll get a directory with all of the clean outputs. So we can look at just some like docx ones here. So you'll see a JSON output for each of the documents in there. The idea long term is to basically kind of have a CLI and eventually a UI-driven tool that'll take you from source with a bunch of documents to a database sync, like something like a Chroma. To make it really easy to get up and running with your retrieval-based application. And so I think I'm coming up on my 10 minutes here. And now that we got our documents into our vector database, I think it's good transition point over to Chroma, unless there's any lingering questions.
There's a bunch of questions, but I think we can take them in the time after.
All right, sounds good.
Thanks, Matthew. That was great. And thanks, Harrison, for having us. Hello to everyone. I want to talk to you guys a little bit about more, the future of retrieval. We've seen, I think most people using LangChain by now are familiar with the very classic, chat your documents example, but I think it's important for the community to know there's a lot of research being done in this direction. I want to talk about some of it today. So let me just pull up my slides, and hopefully everything doesn't instantly break. Audio-visual software is the hardest problem in computer science, we've come to realize. So let me just pull this up. All right. Cool. The slides should be visible. If they're not, people should scream and yell. Are we good? Great. So yeah, let's talk about advanced retrieval architecture. So these are things that are coming down the pipe right now. A lot of these are still very, very experimental things, but they're worth thinking about because they kind of really influence how we build the underlying retrieval system and how tightly we integrate it with the models. So let's get started with the basics. Everyone by now who's using LangChain is probably very familiar with this fairly basic retrieval augmented generation loop, or this is what you do when you want to chat with your documents. You take your documents and you embed them into Chroma, or you ETL them and then embed them and load them into Chroma. That generates a set of embeddings, which is stored and managed by Chroma for you. And then you put in a query. Chroma will handle embedding that query and returning the nearest neighbor results for you. You hand your query on those results over to the model, and the model generates an answer based on your query, either answering the query or performing the task you'd like the model to perform. Here, it's OpenAI. I'm actually very bullish on the rise of open source models. We're actively playing with Llama 2 to see how well it works in the retrieval augmented generation context. Very exciting, because with something like Chroma, which is also open source, and an open source large language model and LangChain, it means you can run this fully locally. You don't have to egress your data to the cloud, which is something I know quite a number of organizations and a few developers have been worried about, especially if you're working with private data. So the one that I always think of is you want this intimate conversational assistant, but you probably don't want to send a lot of that intimate information over to OpenAI or whoever else of the world you like. So that's the basic loop, right? And it's really easy to try with Chroma, and Chroma is built into LangChain. Fairly straightforward. You can get us from the vector stores page. So what's coming next? We are really barely getting started with retrieval in AI and with large language models. The retrieval systems that we have today are really just based on straightforward embeddings-based vector search, the same way that it's done in web-based, in semantic search and recommender systems. And it doesn't really take into account the fact that there's an entire large language model here that's also performing the inference task. We're essentially retrieving information and then loading it just into the model's context window, but we could be doing a lot more. So there's a few different questions as well, right? We're talking about what to retrieve, and the default is to retrieve these text chunks. So we take a document, we chunk it up using various data loaders, and then we retrieve those text chunks and we stick those chunks in the context window of the model. But we could be retrieving at the token level. We could be retrieving something else entirely, and in fact, we could vary what we're retrieving depending on the task. And then there's different points at which we could use retrieval as well. We can put, for example, the way we do it today is we take our retrieved chunks and we put it into the context window, into the input of the large language model. But we could also inject retrieval steps into the LM architecture itself. For example, using the attention heads in the decoder layer to figure out which tokens to retrieve. Or we could even inject retrieval results into the model output as well at the output layer. So we basically inject additional embeddings weighted by what the model has generated so far and actually use the model generation as a signal for what to retrieve, which is very interesting. One example of that is the hypothetical document embeddings idea, where we actually use a model response to a query, even though it doesn't have access to the underlying information, to generate something that might be a response to that query, and then use that generation for retrieval. So that's another way to look at it. And then, of course, there's the question about when to retrieve. Typically, the way we do things today is one big bang retrieval step. In other words, we perform retrieval once, we put it all in the context window, and off we go. But there's no reason that we can't, for example, retrieve as the generation is happening. So as each new token is generated, we perform a new retrieval step and then feed that into the model. Or we can actually conditionally retrieve. So we know that, okay, the model here is at, for example, a high perplexity in the next generated token. Maybe this is a good time to ground ourselves into the retrieved information. So there's a lot to explore. There was a workshop on this at ACL very recently. A lot of great papers were examined. I've got the source up on the slide here. If you're interested in this stuff, I really recommend digging into this, because a lot of this is coming down the pipe. It's been demonstrated that this really helps the models perform very well on certain benchmarks. And so working out how this works is like going to be very important. So again, there's tons of papers around this right now. We can retrieve entities rather than just document chunks. We can retrieve tokens either directly using like this K nearest neighbors approach, or else adaptively, where we use the attention heads, as I mentioned. We can feed tokens, retrieve tokens, or retrieved embeddings of tokens directly into the intermediate layers, as I mentioned, so into the decoder head rather than in the encoder head or in the top level of the decoder-only architecture. Or we can also retrieve from basically within the model's context window itself and feed that in appropriately as part of the retrieval strategy, which is very interesting for long context window models, which we know tend to get distracted and tend to sort of forget parts in the middle of the context. If you have a look at some of the recent papers around large context windows and how well they actually perform, the attention mechanism is fairly limited and could be augmented over a longer context window using a retrieval-based strategy. And then finally, what we talked about, when to retrieve. You can retrieve everything at once, we can retrieve every n tokens, or we can retrieve, as I mentioned, adaptively, deciding when we actually want to retrieve and then inject that into the model's context window. So this is all right now very experimental. What's interesting about these in particular is typically, or for at least many of these strategies, you can take an existing off-the-shelf large language model and add these strategies to it. So there are papers like Unlimiformer, which actually take any underlying encoder-decoder transformer and allow you to basically integrate a retrieval setup using the attention mechanism as the query vector. So there's a lot to play with here. It's showing early promise. We think that ultimately this sort of tight integration is very likely and very useful, but it raises a lot of questions around the architecture about how you build retrieval systems and how you actually manage to get these things into the GPU memory. All of these parts have to still be worked out. So yeah, a little bit different from the usual retrieval augmented generation talk and demo, but I thought it would be nice for the topic of this advanced retrieval webinar. I'll leave it either open to QA now, or I'll just hand it over to you, Harrison.
Well, I'm going to ask one question. I think there's a this was great, by the way. I hadn't seen a lot of these. I hadn't seen them kind of like presented in these like what to retrieve, how to retrieve, how or when to retrieve thing. I guess my question would be, I think a big rise in the popularity of language models is that it's really easy to use them and that they're behind an API. And right now, and yes, there's the local models, and I'm also excited about those. But a lot of people are still using models behind an API, not only because they're better, but also because it's generally kind of like easier. A lot of these methods rely on kind of like access to the model that aren't currently exposed by some of like the large API providers. How do you think about that?
Yes and no. So obviously the ones that require injecting tokens directly into the intermediate layers aren't available to you if you're accessing models over an API. But the sort of idea about, for example, retrieving as tokens are generated is completely accessible. Restarting the generation or injecting additional context in the middle of the generation is absolutely available to you. It's just, it's more expensive. It does require more API accesses. But the other thing is by making retrieval controllable in the context of the model generation itself, you can start driving some of those costs down, which is a very interesting direction to take. I really do wonder. I know, for example, that the AI research labs are very actively also pursuing retrieval. And so I wonder exactly where the interface is going to land. Should they provide that kind of retrieval augmentation? It's pretty unclear, and I think it's unclear to everybody right now. But part of the fun in building in this space right now is so much isn't determined yet, so much isn't figured out, and there's a lot of room to influence basically what gets built by starting to work with open source and saying, hey, this works really, really well. And then obviously if it's working really great, then the labs will have no choice, the API providers will have no choice but to provide some version of it too. So we're bullish on that future.
Yeah, I think it's interesting there because I don't know, maybe this is the retrieving context paper or maybe it's a different one, but there's the Flare paper, which does something around when to retrieve. And they use OpenAI, but what they use is the token probabilities to determine if it's low probability, stop generating, do a retrieval step, put it in. But
yep, that's the adaptive retrieval. That's the adaptive retrieval piece with N tokens. Yeah.
Yeah, and so that's doable with an API if it returns the token probabilities. And I think we've actually seen the chat models return less and less, and so it's kind of in terms of information. So.
Yeah, the issue, the reason that they've started doing that, of course, is because it really aids distillation when you have the log probs. And they really don't want you distilling their models. Look, skill issue, in my opinion.
Cool. Awesome. I will chat very briefly about some of the retrieval stuff that we're doing in LangChain. And then we'll open it up to questions. So this is another call to go add your questions to the QA sidebar on the right and upload the ones that you're most interested in hearing answers. I will share my screen very briefly. You may need to stop sharing yours, Anton. Cool. All right. So this is I won't spend too long on this, but basically I'll chat very briefly about some of the edge cases of the classic semantic search kind of RAG style retrieval thing that we see mostly on so a little bit different approach from Anton, still sticking with kind of RAG and in terms of injecting it into the prompt, largely because that's what we see a lot of LangChain kind of users doing, but talking about kind of when does cosine similarity, when does just straight up kind of semantic search kind of fail, and what are some interesting alternatives that we're kind of working on. So some edge cases of semantic search, and I'll go through these in a little bit more detail, and there's probably also a lot more. I think kind of just cosine similarity might get you 80% of the way there, but as you start to want higher and higher reliability, there's a lot of issues that pop up. One of the things that we see is repeated information. Basically, there's some documents have the same set of information. Maybe there's even duplicate documents. This has a few downsides in that it basically just takes up kind of context. So you might not be retrieving the kind. You might retrieve only one type of document, even if you retrieve kind of two types of documents. If there's 5 of one, it will kind of overwhelm a little bit or could cause some distraction. So basically one of the more basic solutions that we have implemented here is kind of max marginal relevance. This is just basically a kind of wrapper. A lot of these use standard kind of vector indexes under the hood. So it's a wrapper around that. It selects maybe the top kind of 100 documents by cosine similarity, and then does a separate kind of almost re-ranking step where it goes through first and then basically chooses documents based on not only their similarity to the query, but also their difference from previous documents that have already been selected. So you get some diversity and you get a diverse set of information coming through. Conflicting information is an interesting one. So you can sometimes have like the same answer from multiple sources. So an example I like to use here is in kind of like your Notion database for your company. You might have some uh, description of the vacation policy in the main homepage, and then you might have some sentence mentioning the vacation policy in like your personal notes or something like that. And very related to this, by the way, is the idea of like temporality, and information can update over time, and maybe be conflicting over time. And the solutions are kind of similar. One is kind of like you can do some importance weighting based on documents. Perhaps you can also include a lot of the metadata in the retrieved results, and then tell the language model to reason, and it will generally be able to reason that more relevant or more recent information is more relevant. If you have a higher importance, you should maybe trust that. And this is where I think a lot of the ingestion stuff and adding metadata to documents appropriately that Matt was talking about, and why I think there's a lot of nuance in loading documents and splitting documents and making sure that you have the right metadata for documents. All this becomes really, really important to give kind of like the appropriate context on when a document was written, how important it was, how much it should be trusted, things like that. This is one of my more favorite ones that we have in LangChain. It's called the solution for this is the self-query retrieval. But the basic idea is that questions that you get might be more about the metadata than the content. And so if you're doing kind of like a cosine similarity approach, and you're just looking at the semantic meaning of a query. If you have a query like movies about aliens in 1980 or something like that, what you really want to search for, assuming you have a database of kind of like movies, you really want to search on the descriptions for aliens or something like that. And then the 1980, it should be kind of like a metadata attribute that you're kind of like explicitly filtering against. And so this idea is basically using a language model to extract that metadata. Most vector stores, including Chroma, have kind of like metadata that you can associate and you can filter on, and they have a bunch of different operations you can do, equal, greater than, a bunch of other ones like that. And so the idea is to extract metadata from a query along with a semantic bit from the query, and then use those downstream. And then the last thing would basically be questions or queries that require kind of like multiple queries. So it might be asking kind of like, and I call this like a multi-hop question. And I think like an example of this is there's a lot of the original kind of like self-ask questions, like who won, or what is the hometown of the US Open champion in 2017 or something like that. And so first you want to look up, like, you want to do some retrieval on like the US Open champion in 2017, and then you want to do some retrieval on his hometown. And so the idea here is basically don't do kind of like one query and get everything, but rather first look up the answer to the first one and then do a second one, and some type of like agent-like or looping-like approach here, I think is appropriate. Just showing a screenshot of the self-query really quickly, because I think that is that's a fun one because it uses Chroma. We can see that over here where we load up a bunch of documents first, or here I think we explicitly list them out just to show what's going on. So we have the page content. This is the movie database one. We have like the page content, which is a description of the movies, and then we have a bunch of metadata that we can filter on. So the year, the rating, the genre. And so we can load it into Chroma, and then we can see that we just basically provide some information about what the metadata fields are, and then load this self-query retriever. And then now for a given query, we can extract kind of like the query and the filter. So what are some movies about dinosaurs? The query is now dinosaurs. There's no really filter specified here. I want to watch a movie rated higher than 8.5. This is the opposite. There's no real query here, but there is a filter. And so we get this comparator greater than equal to the rating 8.5. And then there's a bunch that combine them. So has Greta Gerwig directed any movies about women? Query woman, and then this filter. This can get like pretty complicated. So now we have a movie or now we have a query. What's a movie after 1990, before 2005? That's all about toys, and preferably is animated. We can see here we have the query as toys, and then we have this complex kind of like conjunction of all those other things. There's a bunch of other retrievers here, and I would comparing this a bit to kind of like what Anton presented on, I would classify these more as kind of like heuristics you can kind of like do on top of your RAG architecture rather than like fundamentally changing a lot of the RAG architecture itself. I think the closest one that we kind of have is we have an implementation of Flare, which is the one that determines to dynamically kind of like do retrieval. But a lot of these rely on not changing the underlying structure too much. You're still injecting stuff into the content of the prompt, and that's partially by design in order to keep kind of like the interaction simple. A lot of people are just using those APIs, and yeah, so I think it will be interesting to kind of like, I don't know. I think it'll be really interesting to see how those APIs evolve and what other kind of like techniques besides just these heuristics become more and more available. That's basically all I have. I don't know if there's anything you guys wanted to add on that.
Yeah, I do. I have something. So, I think we're seeing increasingly people sort of looking at more, like you said, Harrison, more heuristics-driven retrieval pipelines. From my experience in robotics of around 7 years, anytime you have a hand-tuned heuristic-driven pipeline, you are going to put yourself in a rat race of dealing with edge cases. And I think we're going to enter that era before long. I think the long-term right solution for this is figuring out how to build flexible retrieval-oriented models and couple these things more tightly together. Again, in my experience, it's possible to get something that kind of works most of the time. And that's kind of the trap of adding more heuristics, is it will seem to kind of work more often. But what you won't notice necessarily, unless you know to look out for this, is the variety of edge cases actually increases as you add more heuristics. So just something to watch out for. I think that what we need really are like very general approaches and general methods that work in all kinds of different contexts, rather than talking about like, this particular thing works here, this particular thing works there. But at the same time, I think it's really worth exploring a lot of those heuristics because they might point us in the right direction long run. That's just something I thought I'd mention.
Do you have like, what's your estimate on kind of like what's your estimate on like the timeline for kind of like these things? Like if we say there's kind of like, let's maybe like throw like, in like 6 months, will people still largely just be doing kind of like cosine similarity things? And like in 6 months, will the APIs by the major model providers still be the same, where they don't kind of like allow for a lot of the kind of like token level manipulation?
Yeah, if I was to make an educated guess, and in the 6 month horizon, I think is a really interesting one. I think in 6 months, we're still going to be living in the world where most organizations and developers haven't adopted retrieval augmented generation at all yet, right? It's easy to forget just how, like, just working on this stuff instantly puts you 3 or 4 months in the future of everybody else who's not actively working on it or thinking about it all the time. So I think in 6 months, we're still going to be in that long tail of adoption for even basic retrieval augmented generation, which is very powerful as it is, right? I think it's, we're talking about these advanced methods, but I think it's important to remember the basic idea here still is very powerful. And the ability to interact conversationally and non-linearly with large corpuses of text is just fantastically useful across a variety of industries and use cases. And we've seen that with Chroma's adoption, right? Now, that said, I think at the leading edge, we're going to, in 6 months, I would say at the leading edge, we're going to see practical deployments, the first practical deployments of these more directly integrated retrieval strategies for organizations that are very forward about this and like are committed to pursuing this as a strategy, instead of the organizations who are kind of like, shit, we got to do something with AI. And the first thing they think to do, of course, is document-based question answering, which, again, not to denigrate that. I think it's actually tremendous. In terms of what I think the AI research labs are going to do, I think, look, it's in their best interests, and I know they're actively working on this. And it's a very interesting question for us as a business, for us as a research group, to know what that interface might be like, right? And I think the best way to influence that is to show what works as quickly as possible, which is why we're bullish in particular on the open source models, because we can figure out what works. But yeah, I think I would suggest that in 6 months, I would be very surprised if we didn't see some retrieval interface being offered by a API provider. However, I think that's going to look a lot more like, your data is in Azure or your data is in GCP, and you could hook it up to a model rather than providing an interface to an external retriever. I think the long run, based on how the software business really runs, and especially at the enterprise level, especially at the data product level, which ultimately what retrieval systems are, it's a data product. Enterprises want control of their own data. Enterprises want their data to be sitting in infrastructure that fits neatly with what they're actually doing as a business, as opposed to what fits neatly with the API providers' infrastructure. And so I think there's going to be a great demand for sort of being able to do all of the different retrieval stuff inside their own VPC, inside their own cloud. So regardless of exactly how the API providers give it to you, I think that running it, the question that everyone will have is okay, well, I want this entirely inside my own VPC. How do I do that? How do I not send my data over to somebody else or egress it? Regardless of worries around the labs training on your data, which they've promised not to do, but how are you really going to hold them to that? Can you prove they didn't train on your data? I don't know.
And then I guess
there's costs, right? There's costs of egress, there's costs of network, and these things become very large and non-trivial when you're running at enterprise scale.
And one other just general so in the you had the, I forget what you had. You had the what do I retrieve? How do I retrieve? How do I use the retrieval? Something like that. There's still even whether you're retrieving text or tokens, or whether you're retrieving once or every step, you're still doing some retrieval at some form. And that right now is generally kind of some cosine similarity thing, but there could be kind of other retrieval mechanisms. How do you see that retrieval, regardless of where it happens and regardless of what it's retrieving, kind of evolving? Because I think a lot of your talks was about the different ways you can use the retrieved things.
Yeah. So here's the thing about cosine similarity. It's a fixed metric, right? But the whole point of AI is it's flexible and adaptable. And I think ultimately how we deal with relevance needs to be conditional on the query, the task, and the target model, which means that you need to adapt. If we're doing vector-based retrieval, which I suspect we will be in 6 months, because it's just insanely flexible, what we will do is we will see the space in which we're performing retrieval adapted on the fly. So it will still be, one way to look at this is not cosine similarity versus L2 versus whatever, but the fact that let's say one example of what could happen, and we're already seeing it now, is you can use the attention mechanism of, say, the decoder head as a query vector into our latent space, and then it's basically the dot product similarity there is finding the most attended to tokens, right? But that's kind of adaptively changing the space. Another way to do it is to have some model, for example, that conditions basically applies a linear transform onto the vector space, which is conditional on the query as it comes in. So you train this model, and it says, okay, for this kind of query, let's say the example that I always used to give was I'm looking for angry tweets. Okay, I need to expand the angry dimensionality of the embedding vector, and I need to reduce the other dimensions. And that's when you're expanding some dimensions and contracting others, it's an affine transform. So all we're doing is learning a model that can generate an affine transform, which is very neat, right? That's a very different, I want to answer query give me all the tweets about COVID. Okay, I'm gonna weight that differently to give me all the angry tweets, right? And so we're changing the vector space on the fly, and it's actually very cheap to do, because the beauty of affine transforms, especially when they're invertible, is you can apply that transform to the query instead of recalculating the entire vector space itself. So I think that's very promising and on the horizon. And again, one way to do that, when you think about what the attention mechanism in a transformer actually does, is it reweights the vectors as they propagate through the layers. So some sort of basic attention-based model could be very useful on the query side. So I think that we'll see something there pretty quickly. It's still cosine similarity deep down under the hood, right? But it's what you do with it that changes.
All right. Enough of my bad questions. Let's move on to some audience questions. So for these,
I saw one question from Louise in the audience about if there's a generic way to find titles and body text from the HTML. So I just wanted to show something on that real quick. What we pull out with Unstructured, that's actually really easy. So just now, I just took one of these links that we were processing for the example. And you can see here, we're going through and categorizing, for example, title and narrative text, which is just like the body text. Once you get the elements, really easy to filter down to those two things. So we just grab the title here. So this one's about fighting over a docking spot, and then you can easily patch together all of the narrative text items to get the body of the article. And again, the power of what we're doing with Unstructured is that this is showing it for an HTML article, but it could be a PDF, it could be a PowerPoint, it could be a Word document, or whatever else, and it would still work the same way in Unstructured. So thanks for the question there. Just wanted to show an example of that real quick.
And then, Matt, can I ask a question about this? How do you have a recommended? And I think we do some of this in LangChain, maybe, and if not, we should probably do more. But do you have a recommended way for like patching all those elements together into chunks of text that you'd store in a vector database?
Yeah, so we're actually working on some stuff around that right now. So like traditionally, like we'd kind of like pull out. There's like kind of two modes to do it in LangChain right now. Like one is what's called single mode, and that kind of grabs the whole document and tosses it in there. And then we have what's called elements mode, which will be like, hey, like it'll kind of put the title will be an individual entry, for example, and the narrative, like a narrative text paragraph would be a section that goes in there. One of the things that we're working on now is coming up with using the element types to come up with like good chunks. And so like what you'd like wind up with on the other side of that is like, hey, like here we found like a title or like a subheading or something like that. We're gonna get that, and then all of the body text under that, like that's gonna become one chunk. Kind of like go through documents and kind of break it down smartly that way. That's not in right now, but it's something that we're actively working on, and we should be rolling out something on that here in the next couple of weeks.
Nice. I'm excited. I'm excited to see that. I think that'll be really good. So there's some. Okay, so taking a look at the top question, and then there's another question down below. And it's basically about kind of like doing retrieval at scale in production. So like the top question, what are some of the best practices for retrieval for very large databases? For example, a database with 40 million news articles. And then there's also another question down below, which is how would you go about deploying everything to be used for production? So I'm going to lump these two together to basically production retrieval. Yeah, on both the vector database as well as the ingestion side. Like, how do you guys think about and tackle that?
Yeah, do you want me to go first?
Yeah.
I mean, we spend a lot of time right now. Actually, Chroma's main engineering focus right now is productionizing retrieval for AI applications. Is what we're really pushing for, and that scale question is the number one thing we're addressing. We're rolling out our distributed systems version very soon, which will effortlessly scale horizontally. 40 million entries, even chunked into, I mean, they're news articles, so they maybe get 3-4 chunks out of each one. That gives you on the order of 120 million. It's a very reasonable scale. It's actually not unreasonable whatsoever. Now, you could even process that scale in single node Chroma today if you have a machine with a lot of RAM, because you're currently on single node Chroma memory bound in terms of retrieval efficiency. The reason for that is because the vector search part of the database runs in memory. It's the way to do approximate nearest neighbor efficiently. So 120 million chunks from 40 million news articles isn't unreasonable even today. Just as a rule of thumb, on my 16 gig M1 Mac, which roughly has half of its memory used by random applications at any given time anyway, I can do 1 million vectors, no sweat. There's also other strategies which are coming down the pipe, which will make it more efficient. But the answer here is basically use something that'll scale multiple nodes to multiple nodes easily horizontally if that's what you need. Otherwise, just grab a single big node and do it that way. There's other efficiencies to win here. There's dimensionality reduction, which obviously means you need less memory because the vectors you're actually searching among have fewer dimensions, just fewer floats to store in memory. There's also, writing part of the index to the disk and only keeping a part of it in memory, and you can do that adaptively in response to query patterns. But the answer today is basically just like more RAM is good. On the part of deploying to production, I mean, there's a lot of considerations around here. Chrome is deployed in production as a single node service today. You can run it. You can even also run it like as a virtualized distributed system or virtualized multi-tenant system by having several Docker containers running on a single machine, just as an example. We've made it as straightforward as we can at the moment to deploy into production, but everything, it's a little too bare bones. We're definitely working on making that more robust. You have to sort of, put it behind your own server, do your own authentication, do your own token passing around, but we're making it easier all the time. But the main consideration to like making this work is just make sure you have a machine with enough RAM.
And what about on the data ingestion side, Matt? How are you guys tackling that?
So right now we're actually like really simple. We have it's actually an open source container that you can, kind of pull and run wherever you'd like. Like really kind of the heaviest lift from an infrastructure standpoint is on the PDFs and images where some of the workloads are model based. And so like availability of GPUs can help for those. What we found though also like running this internally is that you can kind of run a lot of like instances of it against like using CPUs in parallel, and that's done pretty well. But like from our perspective, we've been trying to just kind of like keep it simple, kind of create these containers that you can take and put wherever you'd like, and then once that's up and running, try to make it so that it's document in, structured JSON out. And again, we have like sort of the integrations to make that easy to use with stuff like LangChain too.
Cool. I see one question down below, which I think would be interesting to get both your guys' perspectives on. Any advice for retrieval on context-dependent questions or time-based information? What were recent developments in XYZ? And I'd maybe categorize this as like, when the query itself isn't just something that you maybe want to do semantic look upon, but has some kind of like mention to some other thing. How do you guys think about that? Both from like, what should people be storing in the vector databases, and how do you help people extract that information during ingest time?
Yeah, so we've kind of put a lot of thought into that around basically kind of the metadata component of document pre-processing. And so like, especially for stuff that's time dependent, kind of like extracting stuff like, like when the document was last modified, if we can pull a date out of the document and like store that, that sort of thing is really helpful. And then like one of the things that we kind of have experimented around with internally is basically just kind of cosine similarity with like a time decay. Basically, we found was pretty simple and kind of like easy to implement to get stuff, that's like kind of like biased towards more recent information. I'm sure there's more complex retrieval methods that you could do to get at the same thing. But like really from like the data preprocessing perspective, it's about pulling all of the information out of the article or the document that you can use for that conditioning step. That's really the crux of it for us.
Anything on your end, Anton, and with regards to how you see people use metadata and
Yeah, that question actually around like time-based stuff has also come up for us. One of our hackers in residence was working on things that need to update over time, and so it's a question we've been thinking a lot about. And you start thinking about like journaling in the context of vector-based retrieval. I think metadata filtering is like important. I think that it definitely helps you scope your query. One interesting thing that we've seen people doing is like basically using a model to do entity extraction and then injecting that as an additional metadata filter for query relevance. Again, to me, it feels like a short-term stopgap. The model should figure that out for you. It should know, oh, these are the relevant entities, therefore I'll weight those parts of the vectors appropriately. But in the meantime, I think it's interesting to experiment with this stuff. Sort of my short response here would be like, I would try as much of this different stuff as possible and make it as lightweight as possible to do so in your application and see how well that works. The time thing we're actively thinking about. Obviously, Chroma supports like time fields in metadata, and you can search inside time ranges. But when you think about the way you interact in natural language, you don't say like, oh, I want to know information between the 26th of January or and blah, blah, blah. I want to know like you want your system to know that your brother's birthday is coming up and you were within 2 weeks of that. So now I should, prompt you to remind you to get him a present, for example, right? Right now, it just feels a little clunky. It feels like we're either not trusting the model enough, we haven't found the way to use them effectively yet, or they just aren't capable of doing this. And so we're like patching over some of these gaps with metadata.
Long context windows. How are they changing how you see people do retrieval?
So we haven't actually seen many people using long context with retrieval yet. I think it's important to remember that like long context doesn't actually mean you just stuff everything into the context possible. There's a paper, Harrison, which I'll link you later, which like, again, and what's interesting about the field today is there's a lot of folklore about what works and what doesn't. And eventually a paper comes out that like empirically supports or refutes that conclusion. But for a while, people have like intuitively known that longer context windows with a fixed attention mechanism kind of mean that the model can't really attend as effectively to every token in that context window. And it's been proven. And it's also been proven that like distractors are really bad. If you add like incidental irrelevant information, the model performance just falls off a cliff very quickly for very little distraction. So what that means is that long context is great for retrieval because it means we can fit more relevant information into the context and we can like appropriately present that in a way that the model can understand and apprehend it. But it means that the longer the context, the more information you can retrieve, the more important relevance actually becomes. Because each time you retrieve your distractor, the model performance falls off a cliff. So it's not a question of just like tuning the k and k nearest neighbors to be 100 instead of 10 and just shoving it all in there. You have to be very, very careful with relevance, and that's something that we're looking at right now. I think longer context windows are great for retrieval. It means we no longer like cut off what we retrieve anymore.
And on this note, one question I have for Matt is: are you seeing, basically with longer context windows, does that change chunking at all? Like, are now people doing longer chunks because they can maybe put longer chunks in, or do longer chunks kind of distract, as Anton was saying, and they make the retrieval step like worse? So how are you seeing people balance that?
Yeah, I think there's also kind of like the cost consideration too. Like if you're processing like a lot of documents and it's like you're paying on like a per token basis, and like throwing like a lot of stuff like into the context window can get like more expensive too. So I mean, I think like with like the models with like longer context windows like coming out, like I think we're seeing like that become more common. But like there's still kind of a use case for kind of getting that sort of like more targeted context as well, both for the reasons like Anton said, and then just kind of like for some like kind of like nuts and bolts is like like if you're processing a lot of documents, like you're going to want to be kind of careful about like how much you're kind of how many tokens you're putting in the setting of the model and that sort of thing if you're using one of the hosted ones.
Cool. All right, let's maybe and depending on how long the answer to this one is, on a fun one, which is basically going back to like different types of retrieval. What do you think about combining graph retrieval, or sorry, what do you think about knowledge graph retrieval combined with vector retrieval? Is this a viable solution? Will everything in the long run end up happening kind of like in the embedding space with transformations, and so this is actually the same as like just upweighting certain tokens? How do you think about this, Anton?
Yeah, interesting question. This kind of idea of like overlaying a knowledge graph, we've seen a little bit of this used as a re-ranking strategy. So you find like related entities through the knowledge graph after you've performed the semantic search. I think there's something here. Naively speaking, embeddings, vanilla embedding models, contrastively pre-trained embedding models don't encode relationships between entities for you, right? It has no knowledge of like how you relate the two concepts of car and bird, right? But that might be relevant to your particular task and application. One argument could be made is, okay, well, that's just a relevance hack, and in your particular application, what you need is to sort of fold and squeeze space such that the embeddings that you need actually end up closer together. So entities that are related in your knowledge graph should just appear, similar under the vector search. But I don't know if there's a good answer here. And I think this is really one of the questions. How do we encode these like binary relationships, or how do we encode even these like weighted relationships in just AI in general? Right? We don't have a good way of that. It feels like in many ways just using kind of the training distribution as the target for the loss is like fighting with one hand tied behind our backs. It doesn't encode any of the sort of logical relationships. It only encodes the statistical ones. And ultimately, of course, we see the emergent behavior and if you play with these models, you probably have the same sense that I do. You see these logical relationships emerge as a consequence of the statistical behavior, but the actual logical relationship isn't there, which is what causes them to hallucinate, for example. Like, that's what hallucinations are. Hallucinations are statistically likely generations that ignore the logical or the grounded representation of the real world. So knowledge graphs may be one way. Ultimately, it comes down to this question of like, how do we represent information in a way that's legible to AI that it can work with it? And I think that that's a really broad and interesting research question that everybody's working on.
Yeah, the only thing I'd add in there is that the value is definitely there on stuff like kind of like augmenting with like knowledge graphs and stuff like that. The difficulty is that knowledge graphs are like really difficult to construct, so it's a lot easier to get up and running with like a kind of like a vector search powered application. So I think one of the things you might see is kind of people use vector store based applications as V0 to kind of like get off the ground, and then over time, as the systems mature, you add in those sort of like higher cost like components like a knowledge graph that take a little bit more time to get up and running. Yeah, like it definitely is like I'm definitely like interested to see how that evolves. Yeah, like at the same time, I think it's hard to replace kind of like the ease of getting up and running with kind of like the the current like RAG type architecture.
All right, that seems like a great place to end it. So with that, thank you both for joining. This was a lot of fun. I learned a lot. So these are always when I learn fun stuff, those are the most fun webinars. So I appreciate you guys coming on and talking.
Yeah, thanks for having us. Really appreciate it.
Thanks for having us. Yeah, I look forward to sort of continuing to invent and experiment here.
Yeah, I really liked what you said about like, it's the best thing to do is just try a bunch of stuff. Like, I think we're in just that phase. And so, yeah, excited to
strongly agree. Strongly agree. And like, everyone here on this webinar is building tools ultimately for experimentation. I think it's a big part of the way Chroma builds things, the way LangChain builds things. And so just making it easy for people to try this stuff, I think, is a big deal right now. Yeah.
And I think, and just to find, everyone in the audience should try out everything. And,
yes.
Thank you guys for tuning in. Hopefully you got some ideas. Fun time to be alive.
Yeah. Thanks very much, Harrison.
See you guys.
Thanks.